Hey, what's up? It's Jake from Nimbus DevOps, and let's talk about working with JSON. So, what the heck is JSON? Well, JSON is an acronym, and it stands for JavaScript Object Notation. And it's a subset of the JavaScript language. It's been around for like 20 years. It's widely adopted, well known by most languages, honestly. And even though it's actually language independent. You can read about it on json.org, but I will just kind of leave it to you to do that on your own. So I'm going to make a file called json underscore basic.py. So JSON is based on two structures, a collection of a name value pair or a key value pair and an ordered list of values. It's pretty straightforward to realize these two objects map to a dictionary and list data types in Python, respectively. So as data types, JSON offers strings, numbers, objects, and values consisting of true, false, and null. And I'll give you a little example so you can see. So let's import sys and let's import JSON. Now let's say I want to make some data. And I'm going to be using these brackets because JSON uses brackets. And I'm going to say I have big number is my key, 2 is my value, times 3141, some huge number. And then I'm going to have a max underscore float as my key, and my value is going to be sys dot float underscore info dot max. And then lastly, I'm going to make a list as a key, and the value is going to be a list 2, 3, 5, and 7. Okay, so let's do something with this. So if I go json underscore data equals json dot dumps for data. And then data out is going to be json.loads for JSON data. Let me use that thing I just created. And then I'm going to assert data exactly equals to data underscore out. And this is the JSON and the back data matches. Okay, so what is going on? So we start by importing the sys and JSON modules, and then we create a simple dictionary with some numbers inside and a list. We want to test serializing and deserializing using very big numbers. So both int and float when we put the 2 to the 3141st power and whatever is the biggest floating point number our system can handle. We serialize with json.dumps, which takes data and converts it into a JSON formatted string. That data is then fed into json.loads, which does the opposite from JSON formatted string. It reconstructs the data into Python. And on the last line, we make sure that the original data and the result of the serialization and deserialization through JSON are a match. Okay, so what is this gonna look like if we do this? Nothing. It just does what it needs to do. So there's no errors. So let's see what the JSON data would look like if we printed it. So if I said, let me just comment out all this stuff and let's do something new. Let's say I have an info object, and in this object, I say I have a full name will be Sherlock Holmes, and then comma, let's do an address, which will be another object. So the value is an object, and we will say street is 2218 Baker Street, and we have a zip, which we will say NW16XE, comma, and then we'll have a city, which of course will be London. And then lastly, we have a country, which will be UK. Okay, so there's my info block. So now let's print json.dumps info, comma, and then we want to indent equals 2, and let's sort by key. So sort keys equals true. Sorry, not Canadian, sorts. There we go. So we create a dictionary with Sherlock Holmes data in it, and you'll find that all the information is in there in JSON format, and we'll call JSON dumps, and we told it to indent with 2 spaces and sort keys alphabetically. So what does that look like? Let's look at the result. Address, and then we see city, country, street, zip, and then the full name. So it's actually an address starts with an A and full name starts with F. So it's sorted all these alphabetically. The similarity with Python is quite evident. The one difference is that if you place a comma on the last element in a dictionary, as is customary in Python, JSON will complain. So let me show you something interesting. So let's say I have a tuple. Let's make a file called json_tuple.py. And I'm just going to import JSON, and we'll make it nice and simple. So let's go data in equals, and then let's create an object, and we'll just make one. Let's just say a tuple, and then let's give it like 1, 2, 3, 4, 5. Okay, so there's my data. So I could say JSON_data equals JSON.dumps, and then I'll take my data in, and then I will print JSON_data, and I should get the tuple. I won't even say what I'm gonna get. I'm gonna get the tuple, and if I do a data out equals JSON.loads JSON_data, and then I want to print data out. So this is the dump, and this is the load. Okay, so let's see what is the difference. Clear. I ran the wrong program. All right, Python JSON_tuple. I get almost the exact same values. Almost. So we used a tuple instead of a list, and the interesting thing is that conceptually a tuple is also an ordered list of items. It doesn't have the flexibility of a list, but still is considered the same from the perspective of JSON. So as you can see by the first print in JSON, a tuple is transformed into a list. Naturally, then, the information that the original object was a tuple is lost, and while deserialization happens, a tuple, like a_tuple, is actually translated to a Python list. It's important that you keep this in mind when dealing with data, going through a transformation process that involves a formal or like any kind of formal agreement, like a decided format that only comprises of a subset of data structures, because it implies there may be information loss. So in this case, we lost information about the type, like the tuple versus the list. And we could even and we could probably even just like print type JSON_data, and then we could do print type data_out, and see what does that do. So one's a string and one's a dictionary. So the types are completely different. And if you compared them, you could say, is one equal to the other, and get a true or false value. So data may look the same, but it's not always the same. So you need to be very careful about this and test it thoroughly. It's a really common problem. You can't serialize all Python objects to JSON because it's not always clear how JSON should revert that object. And think about date time, for example. An instance of the class is a Python object that JSON won't be able to serialize. If you transform it into a string, like 2022 April 24th, and then the time of whatever in Zulu, it'll be an ISO 8601 representation of date with time and zone information. What should JSON do when deserializing that? Should it decide it's actually deserializing into a date time object? So JSON's going to do it, or does it consider it as a string and leave it the way that it is? And what kind of data type is it? And can it be interpreted in different ways? So just questions like that. The real answer is that when you're dealing with data exchange and interchange, you often need to transform your objects into simpler format prior to serializing them with JSON. So the more you manage to simplify your data, the easier it is to represent that data in a format like JSON, which does have some limitations. So in some cases, though, mostly for internal use, it is useful to be able to serialize custom objects. So I will show you how to do that with a couple examples with custom encoding and decoding in the next section. So thanks, have fun.